This tutorial is about calculating infusion rates using drops per minute. To get the most out of this tutorial, you need to have looked at the tutorial about calculating infusion rates using mils per hour. Clearly, there is something that links the two together, because mils and drops are both measuring liquid, and hours and minutes are both measuring time. And in fact, if we multiply the mils by the drop factor, this will turn the mils into drops. And if we multiply the hours by 60, this will turn the hours into minutes. So one way of doing this would be to multiply the mils by the drop factor, and this will give us the drops. And then we can multiply the hours by 60, and this will give the minutes. The only drawback with this method is you can end up with very, very large numbers over here, and so this division could become quite difficult. So I'd like to show you another way to do it, which a lot of people said they like because they feel it's a bit of a shortcut. In some of the drug calculation exercises you'll have done, you'll have noticed that there are two main drop factors. One is 15, which is usually for blood, and the other one is 20, which is usually for clear fluids like saline. So in fact, this part of the equation will either be 15 over 60 or 20 over 60. And these fractions will cancel down or simplify to 1/4, and this will cancel down to 1/3. So in fact, what you can do is work out the mils per hour separately, and then if you have a drop factor of 15, you just need to divide your answer here by 4, and if you've had a drop factor of 20, you can just divide your answer here by 3. Let's have a look at an example of this. Okay, so you work out the mils per hour separately, and then if the drop factor is 15, you need to find 1/4 of it, and that's the same as dividing by 4. And then if the drop factor was 20, you can take this answer and find 1/3 of it, which is the same as dividing by 3. Let's have a look at an example of how this would work. Okay, let's look at question number 1. This says 800 mils of blood is to be given to a patient over 5 hours. What is the infusion rate in drops per minute if the drop factor is 15? So first of all, I'm going to work out the mils per hour, which is 800 divided by 5, and we can write this like this. 5s into 8 goes 1, remainder 3. 5s into 30 goes 6, and don't forget the 0 on the end. So the first part, the mils per hour, is 160. And now, because my drop factor is 15, as we've seen, I just need to divide by 4. And this one's very easy. 4s into 16 goes 4, and don't forget the 0 at the end. And so our answer is 40 drops per minute. Nice and easy. Okay, let's look at question number 2. A patient needs 1 litre of normal saline for 8 hours. The drop factor is 20. What is the rate in drops per minute? So first of all, we need to work out the mils per hour. So we need to turn the litre into 1,000 mils. And this is going to be given over 8 hours. Now we can use that very nice and simple halving method to work out this. The same as 500 over 4, which is the same as 250 over 2, which is 125 mils per hour. And now, because our drop factor is 20, if you remember, this means we need to take the mils per hour answer and divide it by 3. And this we can lay out like this. I suspect I'm going to have a remainder, and so then I place a decimal point and a naught to deal with this, and dividing by 3. 3's into 12 goes 4, 3's into 5 goes once, with a remainder of 2. Now I must line up my decimal point. 3's into 20 goes 6, and now I can stop, because the answer for drops per minute must be in a whole number. So I can look at the number 6 and see that this will round the number 1 digit up to a number 2. And so my final answer is 42 drops per minute. Okay, I've skipped to question number 5 now, because this one's slightly different. We've got 100 mils to be given for 50 minutes with a drop factor of 20. What is the infusion rate in drops per minute? Now you'll notice here that we don't have hours, we already have the minutes, and so we don't need to bring in the number 60. So in fact, our formula for this will be 100 mils of fluid multiplied by the drop factor to turn the mils into drops. This will be 2,000. And then we have no hours and just minutes. So we can take the 2,000 drops and divide it by the 50 minutes. I can cancel a 0 on top for a 0 on the bottom. And you should be able to see that 5's into 200 goes 40 times. And so our answer is 40 drops per minute. Nice and easy.